Okay, hello everyone, and welcome to another Allot Smart webinar. The subject today is network congestion, and the question is rhetorically asked, can it really be managed? We wouldn't have a webinar if the answer was no, so a little spoiler alert, we will be talking about how to manage network congestion and what you can do about it as a service provider. And so let me introduce ourselves. My name is Michael Schachter, and I'm here today with Moti Goldstein, who is AVP of Product Marketing, Product Management at Allot. And we will be taking you through the topics today. A little bit of just some housekeeping instructions before we jump into the actual webinar. So first of all the registrants and participants will receive a copy of our QOE survey, industry survey that we did just a little bit earlier this year. We will be referencing the survey during this presentation, and it has a lot of insights about what your colleagues in the industry think about congestion and how to manage it, especially looking forward to 5G. At the very end, we're happy to answer questions, so there will be a Q&A session if we have some time. So please use the Zoom Q&A window, not the chat window, the Q&A window, and we will try to get to everything as time permits. And if not, we'll try to get back to you offline if instructions have to reach you. During the course of the webinar, there will be a few poll questions. Some of them are to help us get to know you better. Some of them are to see what your thoughts are on some of the topics that we're discussing, and also to compare them to the survey. So we'll have a few poll questions, and we appreciate that you will participate so that we get a wider survey answers and we can compare them. The webinar is not focused on Allot products, and you're of course all invited to visit our website because you have a host of traffic management and other should be of strong interest to service providers, and do touch on some of the topics that we are going to discuss in today's webinar. So that's the introduction. We'll be talking about, as I said, network congestion, the QA survey, some of the highlights, but there's plenty of material in the report that we'll be sending to you. And then we'll talk about how network congestion really can be managed. All kinds of different tools and techniques. Some of them really, kind of cutting edge. I think it'll be interesting. And so that is what we've got planned today. Before we get started, I do just have a couple of poll questions that will help us kind of understand who you are. So let's just do two quick questions, and then we'll jump into the webinar. So the first question has to do with yourselves. For us to understand, are you predominantly fixed CSPs? Are you mobile or converged? Are you perhaps enterprises that sell into the CSP industry, or something else altogether? And then I'm not entirely sure why you're here, but you're of course welcome to be with the webinar if you find the topic interesting. So it'd be great if a few more people could answer the survey. I'll give it just another few seconds. And right, so if you're a CSP, are you fixed? Are you mobile? Are you converged? Are you an enterprise that sells to CSPs, or are you in some other industry altogether, and perhaps you're thinking about private mobile networks, which is perhaps the exciting development coming down the line. Okay, so let's end the poll and let's take a look at our results. Okay, so predominantly CSPs, if we add that up, and then enterprises that sell into CSPs, and another 20% of you are in some kind of other field, but I think this is a good distribution and it should be interesting. The next question, and then we will go on, as I said, to the actual content. And so within your, within your employee, you work more in engineering, marketing, operations, security, or something else altogether, and that will also perhaps help us focus a little bit of the content to fit. Okay, we'll give it another couple of seconds, and had a college professor who would always add a question to polls, or are you the kind of person who doesn't answer poll questions? Which put you into a sort of a philosophical dilemma. Okay, let's end the poll and we'll see a very nice distribution between engineering, marketing, operations. And it seems that our targeting is working well because we do have a whole nother security side of the business, and that's not what this webinar is about. So we've got the right people here, so let's get started. Okay. I will proceed with the survey, with the webinar. Here we go. So Moti, we're talking about congestion management and traffic management, traffic congestion. And, you know, I think like most people, and I certainly experienced it on my way to the office today, when we hear traffic and congestion, we think about all the time that we spend in the car on the way to work or to wherever we're going. And it seems like no matter what the highway department does, they build more lanes and so on. You know, the more they build, the more traffic there is. In fact, there's a whole field of study that talks about induced demand, which basically means the more roads there are, the more traffic there is. You know, you build a new cloverleaf and the traffic jam, you know, up the road a little bit, and you add some lanes, and more people think they can just get in the car and drive. And so it never seems to quite, you know, solve the problem. And really, I think the same thing is true for telecom. Cisco, in one of their famous, you know, networking indexing, they talk about how even as broadband speed improves and capacity grows, high-use bandwidth and content and applications grow even faster. And you can see that in the chart below. And so it seems like, you know, telecommunications is just like the highway. Traffic continues to grow. And by the way, you know, we're thinking about moving to 5G and the bigger the pipes, but there's a lot of reports out there that DDoS attacks continue to double and grow. And so not only does legitimate traffic grow when the pipes are bigger, but dangerous traffic, illegitimate traffic, volumetric traffic attacks grow as well. So Moti, you know, where does that leave us?
Well, Michael, I find this analogy very fitting the purpose. Indeed, so you know, we even use the same terminology of traffic and traffic increase, and it is rather the same when you look about the telecom industry and what's going on with the CSPs. They're building more lanes, they're increasing the overall capacity, and traffic just keeps on growing. We see that with the CAGR of 20-30% year over year, traffic goes up, as you rightfully mentioned, both in the market survey and in actual analysis we do on our network. Cisco is doing that, Ericsson, all are having very similar results. So it means it is a global trend, and each one of us, either as a personal end user or as an expert in the industry, we see the effect, and we see the effect on the quality of experience, what you perceive, whether it's a good experience when you perform your daily operation, whether it's your browsing or you're watching a video content or going into the metaverse or whatever you feel. When you have an issue, you feel it. And I think we'll touch base on that later on in this webinar, on exactly what can be done in order to make those roads flow smoother. And fortunately enough, in our industry, it's not all about the length and capacity. We have a bit more, I would say, innovative ideas on how to resolve those issues and improve. But in general, I think when we talk about network congestion, it's like a family of issues. There's a lot of different types of terminologies and different types of congestion in the network, as we usually talk about the total bandwidth and the capacity that the network infrastructure has. And when we discuss congestion, we sometimes try to distinguish between inherent oversubscription. This is part of how we design and build networks. You don't put, if you have fiber to the home, you don't just put 1 gig and multiply it by the number of subscribers you have in the country or region or neighborhood. You do some oversubscription. Let's say the browsing and video and application and the general traffic profile has some statistical or stochastic nature. So this creates the possibility to oversubscribe. But on the other hand, this may cause an overall temporal overlap of traffic, as you know, this is also statistical and may happen. And we defer that from saying we have a congestion in the network in which it's a long period of time. Those are the peak hours when everybody feeling a little bit slowness or sluggishness in the network, and creating the overall effect that the quality of experience, what we experience, getting lower. And I think we can discuss what can be done about that.
Okay, so as you said, it's a little bit more nuanced than my driving the car to work analogy, because there's only so much you can do with the cars and the lanes and so on. So here's an interesting graph from our own tool set that helps. I think will help understand what congestion actually looks like. So if you can talk us through this example.
Excellent. This is an excellent example, Michael. As it's always better to look at real life example, and this is not simulated, this is actual data to show what is a sudden congestion. And here we're talking about the long-term congestion, not about sub-second temporal congestion that may happen in a network. But what we really see here, and if you can follow up, exactly. So what we see here are multiple KPIs laid over a single graph. So we have now, let's say, at the orange line, which is the average RTT, and we're talking about internal RTT, meaning the traffic that goes from the core to the end user and back. So we are measuring the round trip time. This is a very good indication of congestion in the network. When round trip time starts to raise up, it means that you have some buffers accumulated along the way, and this is a sign or an indication for congestion. So what you can see is that during the off-peak hour, the round trip time is getting lower and lower, and as traffic starts to accumulate, and this is a daily pattern, it grows up, and at the first black line, you see that it kind of stabilizes. It jumps up and down, and this is regular changes, but then it's kind of stabilized, and but later on, it starts to go up dramatically. It's a bit hidden by the legend there. Now, if you look below that on the blue line, if you can follow up with your cursor so that the audience may see, this is the blue line, you can understand what is going on. We see that the number of users is being stabilized between those two black lines. Thank you for that. It's stabilized, the number of, let's say, total subscriber over this is a single cell. And then at a certain point, all of a sudden, many users start to log into the network. You see this dramatic increase. The gradient is very high. All users are logging in almost instantly. And this immediately affects the round trip time. And on the other end, if you look at the red line, this is a very interesting KPI we have. This is the activity time bitrate. It means it's not the average bitrate over time, meaning how many bytes have you been able to deliver over a period of time, but the actual bitrate you're receiving once you got a slot to transmit. So we're just measuring on the time you have been transmitting or using the traffic. And this is an excellent indication of the congestion in the network. So you see, obviously, people start to log in. So they're logged in to do something in the network, either to chat, to browse, to read the news, to see some video, or to play games. So the average bitrate goes down very dramatically. But after a while, you can see that perhaps the experience was so bad, if you go back, so some of the users that just gave up. So you see this decline, this hill goes up and down, and users starts to give in, they log out, they say, okay, I'm out of there, or they just exhausted the time, they chatted, they transferred the file they needed and went off to their business. And then you can see on the activity time bitrate that it goes up. So people are logging out, so things are getting a little bit better. And what you can also see in the green line that, and this is rather expected, the overall volume or the capacity of this cell is rather fixed. It may change a little bit due to different links or different capacity of a single link if somebody is moving or behind the wall. But overall, the capacity of a cell is fixed around a certain, I would say, average. So we can see that this was not changed. So the cell is providing as much as the cell can provide, but you see the difference in capacity. And this is something that is happening at a certain point in time, okay? So each cell has its own behavior, and you can further analyze that, but this is just to show an example of what sudden congestion look like.
Okay. And what happens to the subscriber experience?
Yeah, so this is again, I really like this, the metric we've seen here, and this is again, it's a different type of way to look at your network. So what we did here, and this is again, this is coming from a live network of one of our customers, actually a design partner. This is why we are able to share it here with you. And what you can see here is that we took a large population of cell. It's not the entire cell population, but a sample of it. But each line exactly represents a cell, a single cell. And we've added a KPI showing, we call it the suffering KPI, meaning how much users, or what is the percentage of users within a cell that are suffering. Now, what is suffering? We are now looking only on web quality of experience. So we narrowed it down to web browsing only, because when you do those type of application, Michael, you have to understand what you're doing. Looking at a very general view of the network may help sometimes, but it's always better to focus, as the metrics for browsing is different from video. And we know it personally as a user, it's different than when you browse, you chat, or you're watching video, or you're playing games, right? So let's talk about browsing. So here we've used a byte index as an indicator for how long it takes for a page to load. So we as a user, we expect it to be rather high. Okay, so we put a certain threshold saying above that threshold, it means that this user is being suffered. So if you go all the way to the left, you see those are the good cells, right? These are that are very, 1-2% of the subscribers. There will always be a certain amount of subscribers that are suffering because maybe their link properties are rather low, their capacity is very low, so there's not much the cell can do. All the way to the right, you see those cells that is clearly have an issue there. Now, you can dive into it later and to understand whether you didn't size correctly, maybe there's a lot of population, maybe a new building or a new neighborhood or a new road was built around this cell site, causing. But clearly what you can see that over 20% of the users in this cell in average are suffering. But this is not the only way to look at it, because we have another metric laid over. It's like, think about like a three-dimensional view. although in average, one cell or the population around this cell is suffering, we also like to see the distribution, because always in a cell you have a population. So some are really suffering. Those are the red part, okay? The blue part below, those are the subscribers within the cell that actually they're okay, okay? So you may look at one cell that the average may be higher than the different cell, but the distribution is different. And this gives the mobile network operator, in this case, a very good metric in order to look at the cells and define where to start. There's always things to do. We'll touch base on some of them later on, and maybe in details in another webinar. So here you can define where to start and how can I resolve, and you always want to resolve first the most critical one, and to resolve the application that you would like your subscriber to enjoy the best.
Okay, so it's clear, that there's a problem out there, and it's great to have tools. So one question that comes up all the time, and we saw that a little bit in the surveys, although the answers were interesting, we'll touch on it, but certainly in the press, there's a lot of hype that, these problems are about to be, history, because everyone's going to have, super broadband. They're going to have 5G, or fiber to the home, or fixed wireless access, even in remote locations. And so, the first question is, Moti, is this still a problem? Are these tools going to continue to be needed in this new world? I phrased it in a number of different ways here, but isn't the pipe going to be big enough? I mean, that's what the hype is. So,
yeah, first of all, I truly believe that all those technologies of, we see now 5G all across globally. We see both non-standalone and standalone with huge amount of capacity and higher speed. We see fiber to the home penetrating, and we see 5G fixed wireless access offering in many places. And indeed, the speeds are getting higher. The capacity, the bit per hertz is bigger, and as you said, the lanes are becoming wider and wider. This is really correct, and we all are able to enjoy it. Me personally, and I think many of our participants in this webinar as well. But it's very similar, to if I'll take another analogy, it's like, the hard disk. I bought this S20 mobile device with a huge amount of storage, which I said, okay, this is like endless, right? So what happened? A few weeks later, it's all filled up.
Yeah.
So
yeah, I guess the if you build it, they will come.
They will come.
They will come, and they do come. And I think what's happened, and those of us who remember when 3G was going to solve all the problems of the world, and probably everyone here remembers when 4G was going to solve all the problems of connectivity, and we tend to not learn from the past or imagine the unimaginable, but new applications, new services,
Exactly.
it's going to fill up. And so I think we'll talk about. Here's just some examples, right? There are kind of random data points from around the internet, from the Cisco survey, or maybe it was Ericsson, or just random whatever. But video continues to grow, and it's a huge amount of internet traffic, and it's getting bigger all the time. It's also encrypted, which makes it a little bit harder to see what's happening and to deal with. This is an incredible one. 500 hours of video are uploaded to YouTube every minute of every day, right? So these are just, video, and there's gaming, and there's virtual, and there's AR, and there's going to be remote medicine, smart cities, and monitors, and video, sensors, and private 5G networks, or sub networks. It seems that it's pretty clear that the problems of congestion are going to be with us. It may take a while for 5G to get congestion, but it will happen. And so that is why we went out to the industry a few months ago. We did a research project with parks. So it was, anonymous. It was done by a professional research organization. And we wanted to see what mobile service providers like yourselves around the world, what their plans are for 5G, what they think about congestion and congestion management. You know, will it still be a problem? Are there capacity issues, and what is the cost to deal with them? And in general, you know, traffic issues. This was one of those, you know, blind surveys. Nobody knew it was coming from Allot. We aimed for, you know, CTOs, CNOs, CMOs. We wanted to get, you know, decision makers in the service provider industry. It was done over the phone and then with an online survey, some person where they could do it. And we tried to get a nice geographic spread so that it wouldn't, you know, overly influenced by whether a region is further along in 5G deployment. And it was almost 70% tier 1, 30% tier 2. It was entirely mobile, as I said, you know, senior decision makers. So it was an interesting survey population. And before we go to the question, or the results, I'd like to ask you all a similar question, and that is, as we move to 5G, with the potential for much bigger capacity, will traffic detection, the function in the network, still be important? Is it going to be important for you as service providers to be able to have visibility into what kind of traffic is running in your network? You know, is it games? Is it videos? Is it medicine? Is it I don't know, you know, driverless cars? Will it continue to be important for you to be able to drill down and see all of that? Or do you think that the 5G and the slicing and the, you know, distributed architecture is gonna just sort of solve all those problems, and you won't really need that kind of visibility? So I'm going to turn this off. 2 more seconds. Okay. And I will share the results. And so of the people responding, 60% very important and 40% critically important. So that's great, because that's sort of our line of business. And so we're happy to help you keep seeing better what's happening in your networks. But I think it also points to you know, the fact that people don't entirely buy this industry hype. So, you know, we asked where people were on their 5G deployment, and more than half are underway, and it's going to get much bigger during the coming year. And then full 89% said, like yourselves, that it's going to continue to be either very important or critical. You guys were even higher, but you had the webinar kind of priming you for that, I think. But it's clear that there's widespread belief that, you know, just having this big fast pipe isn't going to solve all the issues of understanding what's happening in the pipe. We showed some graphs that didn't deal with the application visibility, but it did deal with the need to understand what's happening in the traffic in the network. So the next question I want to ask you all also relates to these issues of congestion. So you said it's important to distinguish very important and up to critically important. One area where it might be critically important or very important is because maybe some of your users would be willing to pay a premium, you know, a higher fee if their you know, if their SLAs could guarantee QoE. And so the question is, do you think that's true? Will people pay higher monthly fees to get that guaranteed better service, or is that not really an issue? Is that not, you know, why you want to have the visibility? Is it about monetization, or is it about just infrastructure network management? So we'll give you a couple more seconds here. Question clear. We can think about the different kinds of users. We've got, you know, random shoppers. We've got video, TikTok kids. We've got, you know, AR, VR geeks, and so on. Yeah. So let's see what you all think. Okay, so some of you think none, and you know, almost 30% think it'll be 0 to 5%, or 1 to 5%. But again, 60, 70, 73% think that upwards of 6% will be willing to pay. We'll take a look at how, you know, the survey results of that, because we also asked, you know, how much people would be willing to pay. So it's an interesting. It's important because of the growth, because of encryption, to be able to look into the network. And then we asked the 100 service providers who would be likeliest to churn if they were not satisfied with quality. And 63%, a little bit more than video, was gaming, which was interesting because a couple of years ago we asked a similar question, and I guess gaming was more in its infancy. Or your perception of it was as such, because video was around, you know, 70% and gaming was down around 50%, browsing and so on. Interestingly, social networking seems to be pretty satisfied, or you don't think they'll leave over quality issues. So this is interesting, gaming and video, and that speaks perhaps to the 5%, 10%, 15% who might pay that premium for better quality. So I think this is you know, interesting results. Monty, anything to add to this?
Yeah, I think it's very interesting to see how CSPs really look into their business and what are the main both growing traffic types, in this case video, which has a lot of volume, and you see it definitely in one of those which are, let's say, really affecting the perceived quality of experience. And on the other hand, gaming, which may be lower in the total volume, as you rightfully mentioned, but it has a huge impact. So since gamers usually are very sensitive to delay and jitter, as this can totally ruin the, you know, the entire point of having those online gaming and multiplayer gaming, and they will be willing to move to a premium package and pay an extra few dollars more. Now, given the fact that a game can cost you a few tens or hundreds of dollars, and also they will churn and they will go to a different provider if they feel that this another provider may give them, you know, a few milliseconds extra, a lower delay, and we do see that. This is we see that from our customer survey. We see this discussing with customers, and I believe that the audience here would feel the same on those applications, and the impact on the business impact of those applications and the QoE.
Yeah, so yeah, I mean, I think this is clear that congestion and QoE is not just this theoretical, you know, networking discussion, but it has a real business impact on revenue. And then we're going to see another side of the impact as well. But traffic is surging, and CSPs are concerned about churn because of QoE. So that's an important finding. We also asked, you know, sort of general, why do companies measure QoE? How do they measure it? Are they able to manage the congestion? And one question having to do with sort of the regulatory environment about whether you're allowed to, you know, prioritize certain services or applications or user groups. We'll go through this kind of quickly, but why measuring? It's mostly about improving QoE. Also about monetization, so that hints to what we just talked about, being able to build these tiered packages that are based on the QoE, and then some CapEx issues as well. How do they measure it? How do you measure it? So I want to point to the top and the bottom, which is that over half of you are using tools that your network vendor gives you. Some are more real-time, some are more summary. Some of you develop your own tools, but allow me to suggest that having the network vendor who wants you to believe that they've given you a good quality infrastructure, having them tell you how the QoE is behaving is a little bit like having, you know, the cat guarding the milk. they have an interest in making the data look as good as it could. So let's leave it at that. How can you manage it? What can you do if you know you have problems? So a lot of you are still using kind of TCP accelerators. Some of them are more rate limiting. A third are using automated adaptive tools. And I wish I had had more questions that drill down into what that means, because we're going to talk about that topic in more detail. And in terms of regulations, I think the key finding was, and this sort of consistent over the last few years, even with areas that are more sensitive to net neutrality, 22 said only prioritize during congestion, but 55% said you can always prioritize. And so the point is that nearly 80% can certainly prioritize when there are congestion problems. And of course, it has to be, even though there's prioritization, there has to be some degree of fairness. So you can't perhaps prioritize Netflix or YouTube, but you could prioritize video streaming because that's a sensitive application that affects everybody. So, there are nuances, but I think the key thing is that prioritization is allowed in most regulatory environments. Okay, so one other thing I'd like to add, and this, I'm not going to survey you on this, but beyond saying that there are, some X% that would be willing to pay more, it was interesting, let's focus on the bottom data point here, was that the expectation was that people who would pay more on average would pay 10 to 15% more. So if 10 to 15% or up to 10%, if we take the lower end, would pay for premium, it's very instructive that they would pay 10 to 15%. So you can all do your own calculations for your own networks and your own populations of types of subscribers that you have, how many gamers, how many streamers, and so on. And if you don't have that resolution of visibility, talk to us after the webinar. But the point is that there is significant upsell revenue here. That if you can manage and enforce your QoE guarantees, there's good business. So now let's dive down to congestion management. In the next 5 to 10 minutes. What are the ways, and here Moti will be doing the heavy lifting, that congestion can be managed, right? Because we all know what it feels like when we've got the bad QoE. We're all frustrated by it. We've all experienced it as end users. We know, or you all know, what your customers feel, customer complaints, and the call center activity bears that out. And going back to the car industry, so the simple solution is just add infrastructure. But I know that's not what you want to hear, because it's expensive and it's not quick, it's not adaptive. So the question is, and of course, in your industry, it's work and it's resources and it's land and it's towers and it's OPEX and CapEx, and so we're here to talk about better ways to do that in between, and hopefully stretching out the time period of when you actually do need to finally expand. So, the goals are pretty straightforward. You want to be able to deliver high QoE all the time, but especially during congestion, because you don't want to have the people dropping off your network temporarily or churning because of it. You want to be able to get more high quality traffic over the existing resources, right? Obviously there's physics at play and there's limits to capacity, but Moti will go into details about how, even given those limits, QoE can be ensured, and you can get more out of your deployed infrastructure. And you need to know it. You need to be able to see it. You need to have the reporting and the visibility that shows that those sensitive applications and sensitive users are being well taken care of. So Moti, let's talk about, if you will, the three main kinds of congestion management, right?
Yeah, this is correct, and thank you for that. Before we go to that, what I'd like to kind of emphasize and have all the audience keep that in mind, we've been talking a lot about quality of experience, and as I said, we all feel it, you know, in a personal level as well. But on the other hand, we see that in the industry, in many cases, the tools we have to measure those are still lacking. It's rather, I would say, technically, and we have the tools to measure the total throughput and delay and latency. But what we need to always keep in mind that these are not the only parameters, and I will touch this as we go the different strategies. Is we need to keep in mind, and again, each one of you guys and ladies can relate to it on a personal level. When you're watching a video, you really are not concerned with the average bitrate you are receiving. You are much more concerned from things like time to first picture, meaning how long does it take you when you press the button of play until you start watching the movie. You are much more interested if no, you have stalls all of a sudden in the video, resolution changes. So what I'd like you to keep in mind is that there are things that are event driven, and we'll talk about this concept, and I think it's a really innovative approach towards quality of experience and how to measure and understand it. But even before we go to event driven, we have what we call it, quote unquote, static, meaning you have a certain rules, you have a network, you put some kind of rules inside with a prioritization in place, how much bandwidth do you allow to this application, to that user, and so on. There's a huge amount of sets of rules you can deploy in a network that will enable you to manage the traffic. This is like the traffic lights and the signs on the roads. You can be a bit more advanced in the sense that you will apply more adaptive real-time adjustments to those rules, starting from time of day rules. You know when your rush hour is, what is your peak hour, and you may have a different policy depending on the time. You can later on deploy different policy on per location because some locations behave differently, or you can have the network or the overall system itself or the DPI to change the policy and to do adjustment based on real-time measurements of KPIs. And as I referred to a few minutes ago, you can go into a more innovative approach in which you have event-based QE traffic management, in which you prioritize sensitive events that affect the quality of experience of the user. For example, if you are able to identify a browsing session starts, then you can prioritize just the loading of the page, because later on the person would usually read some headlines and decide what to do next. I think, Michael, you can relate to it as a person as well, and this way you will have different strategies.
Absolutely, yeah, absolutely. So when you said the static was like those traffic, so I think this is like a good analogy. If I can go back to my commute to work, you have those lanes that can be changed in terms of their direction depending on, you know, rush hour coming into the city or the end of the day leaving the city.
Exactly.
So the highway, you know, department can't add more lanes, you know, during the day, but they've become a little bit more flexible. I think these are mostly time of day. I don't think they tend to respond to the actual traffic conditions, but since there is, you know, data, but like you said, we can do a little bit more. So you want to dive into static?
Yeah, just to note on that, it's not really static in the sense that it does one thing at all. It does react to the traffic in real time, and this is one of the difference between, you know, a network traffic and physical car traffic, in the sense that a DPI and traffic management system nowadays in Allot, and obviously, but also others, they can identify, and we identify when congestion starts, meaning the total traffic exceeds the capacity, and then you start deploying quality of service rules, which you say, I will put more priority to this application over that application, to that user. There's a huge world. We can maybe refer to it because it will require a dedicated 1-hour webinar just on that. How you apply rules, how do you apply orthogonal rules, which is a very critical capability in today's networking, meaning you can have one rules on the network level, application level, different rules, different priorities on a per subscriber or group of subscriber level. All those tools enables you to smartly manage the traffic. For example, if you have a fixed network, which you know those lanes, you know how much traffic there is there, you can do real miracles in network and save on CapEx investment and provide good service. At the end of the day, we want to provide good service to the end users, right? So there's a lot to do in that. Although usually when people hear the name static, say, I don't like it. I want everything to be dynamic. The management is dynamic, and this is exactly what you depict here in this picture. You see the available bandwidth and you see the subscriber throughput, and once you're below the overall capacity, there's no problem. Everybody can get whatever they want, right? There's nothing you need to do at this stage. You start to kick in the DPI and traffic management and congestion management once you hit that limit. And then you need to decide what you want to do. And here, this is the secret sauce of each one of the different operators. Each one has a different strategy and concept of operation, how they do it. The DPI system can allow you to do all of this traffic management on a per application basis, on a per subscriber basis, and also what we refer to as a sub-application, right? If you have WhatsApp there, it's a different treatment if it's WhatsApp chat or WhatsApp video, right? They have different requirements and different needs from the networks. You can decide what to do. You can also try to really try, if you are able to change the bandwidth, to really follow the bandwidth and change the total traffic per what we refer to as a network unit. Network unit can be a cell, or it can be a port at a BRAS, or some transport, because bottlenecks can be in many places in the network. And obviously, once you go below the capacity, so everybody can get what they want, just don't interrupt. If it works, don't fix it.
Okay, so that was for static, which is much more variable than the name sounds. But what about actual adaptive? What do we do there?
Yeah, in this approach, those are a different set of tools that basically they can work, together in a network. Here you try to identify the quality in each segment of the network, and you want to modify the parameters, the quality of service, to enable the optimal value and to continuously maintain this quality via closed loop feedback of the solution. So for example, if you have a set of metrics that identify what is the quality of experience in a certain cell or a certain group of end users within this cell, you can automatically shape the traffic to a sense to, let me go back one step. Yeah, it's not alchemy, right? We cannot make more bits in the cell than what the cell has. The cell can do what the cell can do. I'm just taking a cellular network as an example. It can support any type of network. But we can make sure that the perceived quality of experience for the users is better. And here again, it depends on the type of users you have, whether it's an industry, whether there are consumers that are mainly interested in broadband and multimedia and so on. So you can shape the traffic according to the applications, sub-applications, subscriber and subscriber groups all together, and follow up on a certain set of KPIs to enable to extract the most traffic and the most experience out of your network.
Okay, so now we've gotten a little bit more flexible. It's not just these rules that are being applied, but it's actual kind of massaging and shaping the traffic, as you said.
Yeah.
Yeah. Okay. And then you've talked a few times about this more innovative event-based that, drills down to is Michael loading a screen or
Exactly.
launching a video or I don't know, placing an order on a financial, stock application. So talk about that because this is really interesting.
Exactly. And this goes back to one of the questions we had in the chat from Mr. Van Dam or Mrs. Sorry, and it really refers, and again, I'm using the example of a cellular network because I think that event-based quality of experience is much more applicable for cellular network due to the inherent nature that the capacity of a single user and of a cell can change rather than dramatically within a sub-second interval. So things are always changing. You're moving within a building or you're driving, your link capacity and link conditions are changing dramatically. If there's some rain or something, same. And it depends on many parameters, starting from the wavelength and all the way to which end user device you're using. So the scheduler, they're using proportional fairness and they try to provide traffic to those subscribers which has the best potential bit per hertz and to do some round robin, so no starvation. But they are totally unaware of the applications, not to mention the quality of experience. And here, you need to deep dive. And in general, we divide into three, I would say, internet event types. One are QoE sensitive instant event. Those what we talked about before. The video starts, the web page is loading, and you can really relate to it as a user on a personal level. It's not like, it's not some mathematical concept or an engineering KPI. It's really something we can relate to it on a personal level. And those instant events are usually characterized by high bitrate for a short time interval. Okay, so the video starts, we get a first buffering going in. Here I'm talking tech a little bit. Or if it's a web page, so you have like a 3 or 5 meg of data going on, and then you have stop.
Okay,
the other time,
point out, excuse me, that we've got 5 minutes to go, so we need to perhaps.
So the other type are the QoE sensitive, but they are more continuous events. You have a conversational application going on or a gaming. Those usually are characterized by a low bitrate for a longer time. Again, we can relate to it as users. And we have the third type, which are non-QoE sensitive events. If you are downloading or doing an update to your OS, you are really less sensitive if it took 1.2 minutes or 1.3 minutes, really. But they are usually high bitrate for a long time, so you can play around with them. And if you have the ability to react to those different types of events, you can really make more out of your network. And this is what we try to show here on the graph to the bottom right, that by using our technology, our solution is referred to as dynamics. Again, we need a 1-hour webinar just on that. This is the solution that enables you as a mobile network operator to extract more from your current resources. Meaning, if we are looking, for example, on streaming average score, we can shift it to the right as if you added like 5 megahertz of capacity to the network, because we can identify the specific instant event and we can reschedule the traffic, so we'll deliver those events fast with maybe some impact on the non-QoE sensitive event. So you're taking a little bit from these, you adding for those, so the overall perceived quality of experience is higher as if you added capacity, and you do it only for specific events. And once you'll be able to do that, you can actually keep your resources at high utilization, because run spectrum and run equipment is not a cheap thing, you know. And so you want to maximize it, but to work on another dimension that relates to the events that affect your experience as a user.
All right, so I think we're getting to the realm of almost magic.
Almost.
And we
Just
talked
okay.
about we talked about, you know, increasing revenue, but now you're also talking about saving or deferring expenses. And we looked into that in the survey as well, and we got figures for, you know, how much or how often MNOs need to expand their network, and what the capacity shortfall is on average. And the average worldwide cost to upgrade a cell capacity was around $18,000. And what we have found with these new tools is that we can increase what we call the virtual capacity by, like you said, up to 20%. So if you do the math, and I'll do in short for you, and you can look at it more in depth in the QoE report, which we'll be sending you. But this is just an example of a small 10K cell network, 3 cells per site. Your numbers will obviously be very different. But just on this kind of a small network, if we can add this 20% virtual capacity, you can defer your expansions in a way that will save you almost $11 million a year. And you know, and so
not to mention the spectrum cost, which is,
and not to mention the spectrum cost. And this is on top of, you know, the increased satisfaction and what we saw as the willingness to pay more, you know, 10% more among 10% of your population. So there's top line and bottom line. And what we've, you know, basically seen here is that QoE and congestion management are business critical. We've kind of run out of time, took a little bit longer, and so we will try to get back to your Q&A questions offline, but thank you all very much. And you know, the takeaways I think are clear. You all get it. You all know that congestion is a problem. You all know that QoE is critical, and you all hopefully understand from our presentation the need for adaptive congestion management to assure the best QoE across the network. So thank you, Moti, and thank you all for joining us.